All right, welcome back, everyone. I hope you had a good breakout group and lunch break as well. We are entering our last afternoon of this workshop, and we're going to start out the afternoon by doing some report outs from the breakout groups, and then go into a group discussion after that. So we still have people signing on, but we are going to go ahead and get started here. And let's see, we'll go in order. So monitoring group A, Jason Otkin. And for the slides, there we go. If we could go ahead and take it away, Jason.
Okay, so we had a very good discussion this morning. So I think everybody that was part of Group A, we're just highlighting a few of the key takeaways from this morning's discussion. Those are highlighted in red in each of these three slides. So one of the things is that we definitely have to have a focus on the stakeholders, on the end users. It's really important to be able to keep them in the loop and to get feedback from them as you develop these different monitoring methods. Perhaps I should start off by saying that our group we did agree upon the definition for flash drought, where we do think that it should focus on rapid intensification or rapid onset. There was some discussion about whether or not we should just look at onset or just look at an intensification. And the reality of it is that there's basically merit in both things, because if you're not in drought, having you may be complacent, you may say things are fine. So having some indication that you are going into drought could be useful. But at the same time, if you're already in drought but are experiencing another rapid leg downward towards extreme or exceptional drought, that kind of intensification is also very useful to get a handle on. Then we also spent some time on talking about which of the various metrics are useful. That there's definitely a need to look at multiple metrics, multiple indicators, but to then also make sure that they are well suited to the region that you're interested in, and that also then feeds into the different sectors. So like agriculture tends to see impacts first. Onset's very impactful, but then that can also bleed into other sectors and parts of the environment. Next slide, please. Okay, so as for the tools that create the most value, we definitely agree that there has to be an emphasis on collecting impacts. So there's always a lot of self-assessments that go on. You take a data set, you look for rapid changes, you find them, you say, look, we have flash droughts. But that doesn't actually get at the impacts. So it's important to be able to verify what you're finding in data sets based on what's actually happening on the ground. So that makes it really important then to really leverage either existing or new types of impacts. So that can be on social media. So you can look at Twitter, other things like that. Of course, state climatologists and other agencies are also very important to consider in that process. Next slide, please. Okay, and then what can be leveraged? There's definitely a need to maximize the data from observing stations that are already there. There's always new things that can be done with existing tools, existing data sets. So it's important to keep doing that. There's also potential to make better use of satellite data, because one of the things that was brought up was that either very high spatial resolution can be very important, depending upon agricultural practices, but it's also there's also parts of the country that just don't have many in situ observations. The cities may be 30, 40, 50 miles apart. So what do you do about those locations in between? And that's where satellite data can come in very handy, because that can get you down to resolutions as fine as 30-meter resolution, depending upon the data set. And then there was also some mention about using tools that are under development or have been under development. in the southeastern U.S. That's the grid DSSAT. I'm not overly familiar with that, but it's a crop model. It brings in radar satellite data, and it's currently set up just for corn, but it could be adapted to do other crops. So I'll leave that here and take any questions later. Thank you.
Great, thank you for those great highlights from your breakout group. We will move into, sorry, monitoring B, and that is Mike Hobbins.
So I put the camera on. Here we go. We got my slides. So we one of the main issues we looked at was for the gaps in needs in research was clearly we need to be looking regionally and seasonally, and be asking and answering the questions as to what tools work best regionally and seasonally. They will be different tools based on hydroclimate and soil texture and a whole bunch of different factors that are regional and seasonal. I think we're crying out for a climatology of flash droughts. This is something that came up in the chat earlier on this morning, but here's a shout out to Jordan Christian, who's wrapping up at OU. He's generating a flash drought climatology based on a bunch of global reanalyses and North American reanalyses, and also looking to NLDAS for CONUS. And I think the sooner we get this out there in the public or in the research community, the better. So we can throw our models up against this climatology and see how we're doing. Obviously, this bleeds over into predictability too, but we were not talking about prediction in this section. The tools that we think would create the most value, education, imagine that. So we need to educate USDM users, listserv contributors, impacted stakeholders on, for example, what the USDM is and what it isn't. For example, not many people understand that it does not take into account forecasts. And we need to inform the contributors about the differences between impacts and drivers for flash drought. We also talked about streamflow. It's sort of been very quiet on the streamflow front here. Largely, obviously, it's a secondary impact, but there's a gap in small stream monitoring. And I forget who it was. Was it Ray Wolf? I think mentioned this website where you can look at small streams, headwater streams in Iowa, for example, and see flash drought impacts on a very small scale. Clearly, you need to stay away from large stem, main stem streams because they're so affected by diversions and storage changes and what have you. But streamflow was one of the needs we came up with. Onto the third one. So we cheated here. I got quite a few bullets. These are sub-bullets. They don't really count. We have a lot of indices and metrics that go into monitoring drought. It would be great if we could get all of those indices and metrics, all the ones that would allow this, in a rapid change index format. And I'm talking about Jason's paper from a few years ago. RCI being rapid change index, and 1, 2, 3 week change maps of those indices that are evolving at the different timescales, and feed them into the USDM and into the USDM contributors. That would really assist this rapid change monitoring. Soil moisture. We spent a lot of time talking about soil moisture. I'll just pick out a few bullets here. We want to leverage the emerging national soil moisture network and the state networks. And people thought that the regional and nationwide maps of soil moisture were not consistent and they were difficult to use. So we want regional nationwide maps of soil moisture in consistent units, standardized. And this was on the USDM authors wish list too, and consistent across states at different depths. And for example, one of the issues that people who use soil moisture have is, well, what is field capacity? If you present data to presented field capacity, I don't know what field capacity is where I'm looking here. More observations of 1,500 stations. This is Trent Ford's stat. Of 1,500 stations, only 100 to 200 have over 20 years of data, which is very difficult to generate percentiles from. And NCEI is making efforts to generate extra data around a given date. But we need more. We need more observations. We need more long-term observations. And we thought that the topsoil soil moisture was most relevant for flash droughts. And there's also mentioned this emerging Interagency Council for Advancing Meteorological Services, something I hadn't heard of, ICAMS, which is a sub-cabinet level. And there's a committee for research that has USDA and NOAA representation. It seems like something we could really use to bring flash drought to a sort of a national policy level. And I think that's what I have. Thank you.
Great, thank you so much. On to the third monitoring group, and Mark.
Thank you. Okay, so let's just dive in. First question here on gaps and needs in research. Thresholds were discussed quite a bit, which we've heard bleed over the last 2 days, right? What are those metrics for change? How rapid? We talked about rapid onset. Intensification was also brought up, but I think we capture that in the next slide. Impacts, very similar to what you also saw in Jason's breakout group review slide as well, that brought up by several. I know Melissa and others spoke to this quite a lot, and how we need that to sort of marry the qualitative with the quantitative to match reality on the ground from the various models remotely sensed. And otherwise, you still need to validate that. So we need a stronger effort to coordinate that. We spoke a little bit about the efforts underway via COCO-RAS, some of the states, the drought reporting done at the Drought Mitigation Center, how we're trying to ingest a lot of those into a common repository. This would all be, but there needs to be a lot more. There's a lot of gaps in that network, and it's not really, it's mostly ad hoc funding. Latency was the other big theme that came out of here for gaps and needs. How do we close that gap into the, going into the operational realm? And David Mako was on our group, so NLDAS is one we've been using in the USDM, but we've also been spurring them on to lessen that gap to get that latency down so it can feed into not just our product, but many other products out there. Next slide. What tools could create value? Well, we've had a lot of talk about this. There seemed to be quite a bit of widespread interest on sort of a resource guide for flash drought communication and education, which would cover a lot of the things, would tie into a little bit of what Mike talked about in his breakout group there. Does rapid onset equal a rapid return to normal, like flooding, and to maybe differentiate how that's not the same concept because of the nature of floods versus droughts and the differences there. So this goes, satellite products, of course, can augment in situ data covering large areas in a uniform fashion. Obviously, some challenges with period of record compared to good in situ data, but again, you need both. You need to marry both, and in situ therefore validates models and satellite products as well. Sectoral applications has obviously been touched on quite a bit. I think we've heard that come through. In addition to region and season, sectoral is important. We've heard people speak to other aspects, but not a lot during this workshop in regards to hydrological drought. What is snow drought? What's the difference there between a critical 4 to 6, 8 week period of no snow in February, March in certain parts of the West? Is that kind of a snow drought or flash drought? And should that be represented, excuse me, in our tools? But also to cover ecological drought. Next slide. Leveraging. This was also, I think, shown or mentioned, discussed in the chat in the general first plenary this morning, brought up again in our group and discussed by quite a few people, actually bringing it to our attention of if you're going to leverage a tool that is already relatively simple and is used by a lot of programs, why not have a flash drought designation on the USDM instead of just S&L? The S as it is now represents about a 6-month period, which gets into more of the seasonal, multi-seasonal drought type of time frame. but flash drought could certainly be something that's labeled FD or something like that, and would only represent like a 1 or 2 month signal that would subset the short down into a flash drought sort of depiction. Is that a possibility? So it's feasible, yes. The tools we're talking about here this week that feed into that could then almost be a subset that guide that specific FD designation. So something to consider. We spoke about the MAP project that was looking at combining indicators and objective blends using machine learning that is not focused specifically on flash drought. How about potential MAP or other research funding to do that for flash drought? I mentioned we are doing an effort like that in our shop too, to look at blending together indicators just for flash drought, not for the existing short or long-term blends that the Climate Prediction Center does, but to complement those. Drone technology was brought up by Christina. On the islands, this could be really relevant, and her context coming from the U.S. Virgin Islands certainly is applicable to what we see and have to deal with on our depictions. You know, for the U.S. Drought Monitor, we also have the affiliated Pacific Islands. We have the U.S. Virgin Islands and Puerto Rico. And this would be a good place to perhaps look at this technology for the various microclimates that they have. And then finally, another thing that could be leveraged that was developed a few years ago, but certainly probably isn't as well known, needs to get out in front of more people, could be, and Tim Hall spoke to this, you know, how do we get best practices and lessons learned? We have stood up and developed a risk management database, but could really use a lot more input and that is based on sectors. But we could really use more population of that database from experts on the listservs, experts at this workshop, and others that aren't at this workshop. That might be something for consideration to leverage an existing tool to expand on that. And that's all we've got. Thank you.
Great, thank you so much. Those were some great thoughts and remarks on the monitoring side of things. Let's go ahead and move into prediction. The first group in prediction would be Andy.
All right, well, hello again, everyone. And I'd like to give a special thanks to our group, who is made up of a variety of people, whether it's the forecasters, the practitioners, everybody in between. I think we had a really nice discussion. So in terms of research topics, you know, what are the gaps and needs? And we always go back to our physical process understanding, because you can't predict something that you don't understand. And I think it was said nicely in some of the discussions here about a cascading and compound extremes. So how did the commingling of precipitation, temperature, wind, vapor, pressure, and not only at the local scale, which helped to create the flash drought itself, but also remotely too. So this is a bear of a problem and requires a lot of work. Now, we also pose the question, whose responsibility is it? Because we have different operational aspects to this. So the local weather forecast offices, they're responsible for, say, week 1. And then our colleagues at the Climate Prediction Center are responsible for weeks 2 and beyond in terms of the forecast. So how do we then meld that together to have a seamless product suite of predictions and communications? So who's involved in that process? What operational forecasters, what translators, what intermediaries? And then also, we didn't choose to highlight this in yellow, but also the predictability and prediction. So going back to what are the predictability limits now? How can we extend those predictability limits with the current tools? And then how can we advance our tools to then prolong the predictability limits? The whole goal of this is to improve weeks 3 and week 4 forecasts, where we historically haven't shown a lot of skill. So going on to the next slide. We also posed a question about lost in translation. And this is kind of a cute title, but it's really the essence of the problem here. And we need communicators that serve as those intermediaries between those that make the forecasts and those that are the end users. So the training of those folks, and CPC does quite a bit of this, but bringing more of those people along really at the regional scale and having the appropriate infrastructure in place. Now, taking the meeting to the stakeholder. So a lot of times, and historically, folks have just sort of sat back and said, well, the stakeholder will come to me. Well, no, we need to go to the stakeholder. Go to the stakeholder, create that dialogue, have it on their terms, and really strengthening the cooperation between and collaborations between everybody involved in the enterprise. So whether it's those making the forecast, those at the state level, the state climatologists, the state agencies, the climate hub, people within region, and also including NIDIS as well, and NIDIS helping to serve as the facilitator. And standardization in terms of the depth of information. So really have the same depth of information across regions. Obviously this is a regional scale problem, so not every region is going to need the same information, but the same depth. So some regions don't get more than others do. And forecasts of opportunity. So here, forecasts of opportunity, what we're trying to do is we're trying to build on what we know, what the antecedent conditions were, and what forecast future conditions may be. So combining the knowledge of the state of the climate, the state of the weather and the climate right now, melding that together with higher skill forecasts that happen over weeks 1 and week 2, and including knowledge of the time of year as well to leverage a better forecast. So on to the final slide. Given what we've heard, what tools do we think could create the most value? And we go back to indicators. Indicators are key to the monitoring community. And when it comes to forecasts, the indicators are actually quite different than those that are used by the monitoring community. So really, we're not speaking the same language here. So using the same language, speaking the same language between the prediction community and the monitoring community, we think that would help to improve a lot of that communication. And then going to things that really go without saying, forecast tools, improving the models, their physics, data assimilation, all the components that make a better forecast. And then using foundational research to then feed into those forecast tools, because again, if you don't understand the process, you're not going to be able to predict it. And then finally, using all of this information to then bolster emerging operational products. And we've heard about the flash drought forecasts that are going to be included within CPC's week 2 hazards. So that's all that we had. Thank you very much, and thanks to our group.
Great, thank you. The next prediction group is Hylan.
Hi, this is Hylan. Can you hear me?
Yes.
That's great. Our group had a pretty live and productive discussion. We pretty much have this active engagement from almost everyone. So here I'd like to thank everyone for the input. So as our group focuses on the flash drought prediction, we also discuss flash drought monitoring and impact as relevant, because these 3 subjects are all related to each other. For example, the prediction and monitoring can be combined all together to produce the flash drought early warning system. And flash drought forecasts are really meant to address the user needs and to quantify the impact. So we need to take into consideration the impact when producing the flash drought forecasts. So regarding the first question, the gaps and needs in research, the group has found that it is necessary, more research is required than the flash drought predictability. And here we have discussed this research need from the science perspective. It will be helpful to better understand the roles of different contributing processes that led to the flash drought initiation and the subsequent development. There are multiple contributors, for example, precipitation deficit, evaporation demand, and impact on the vegetation, and also the feedback between the land and the atmosphere. What are their separate roles for different stages of the flash drought development, and how these processes might interact with each other to influence the flash drought development. And one of the group members also pointed out that it is necessary to perform research to better understand the effect of climate change on flash drought. For example, how the climate change might impact the quantitative assessment of evaporation demand, E-demand, like EDDI. We also discussed the research to better understand the flash drought predictability from user perspective. So what are the implications of the predictability from user perspective? And here, these user perspective would include the impact on different ecosystems and different users. For some stakeholders and farmers, renters, they would have different user needs. So how to address that, how to connect the flash drought forecast to the user needs. And these would require more investigation, especially if we want to provide a quantitative estimate of the impact of the flash drought. And one of the group members has mentioned there are some models, weather-based models, to estimate the crop yield. Such kind of model can be helpful to connect the flash drought forecast and the impact on agriculture. And we also briefly touch upon the research on early warning indicators and also development of in situ data. Even though these in situ data are primarily meant for monitoring, but they can be helpful for the evaluation of flash drought forecast systems. So next slide, please. Regarding the tools that can create the most value, obviously the first item that came to our mind is the CBC product, because CBC is where we develop and produce operational flash drought product for the public to meet the user needs. And currently, we already have this experimental flash drought development tool based on the drought monitoring data, LDS2, and utilize the early warning flash drought indicator, the rapid change index based on evapotranspiration. And as already pointed out in the previous briefing, CBC currently is working on adding the week 2 flash drought forecast to the US week 2 hazards, expect to release next year. So it can be helpful, at least in terms of the lead time of week 2. And also CBC has a plan to developing this probabilistic flash drought forecast. It just currently at its initial stage. It's going to take several years to materialize. And for this development, we would need advanced land surface models, preferably high resolution and with dynamical vegetation, which is important in providing a better prediction of flash drought. And the group also discussed the development of new indices and improvement in observations. Here we need to, maintain the communication with the flash drought monitoring community. We need to leverage advancement the monitoring community make because the forecast product we produce need to preferably use the same index or indices the monitoring community uses just for consistency. And also mentioned it will be helpful to include the satellite-based observations such as those produced by NASA, including microwave-based ESI. If these data can be made near real time, that can be quite helpful. And also the group discussed the importance of leveraging the advancement made in data simulation system, because these can provide more accurate initialization for the drought forecast. So next slide, please. Regarding what current activities that we can leverage in order to meet either the research needs or tool needs, obviously, from NOAA, currently we have this ongoing development of dynamical forecast models and systems such as UFS. Other centers may also have similar activities ongoing, and definitely we can leverage that because the dynamical model forecast serve as a key input for us to produce the flash drought forecast. And as part of this development, some of the models will produce a subseasonal dynamical model forecast. For example, the GEFS version 12 just became operational a few months ago. Definitely can be used as a key input in order to produce the flash drought forecast. And another ongoing activity is the national water model. National water model is pretty unique in that it just provides this real-time hydrological forecast at very fine spatial and temporal scale. And there are also currently ongoing effort between NOAA PSL, Office of Water Prediction, and CBC in leveraging national water model to improve the drought monitoring and prediction. So these national water model definitely can have the potential to be used to develop the early warning system for flash drought. And machine learning approaches, they would have the really good potential for flash drought prediction, even though the group currently is not aware of any ongoing activity or project address that. And last bullet, I think Mark already touched on that. So just in the interest of time, I'm just going to stop here.
Wonderful, thank you so much. And finally, the last prediction group with Joel.
Thanks. So when we were looking at prediction gaps and needs, of course, the first thing that came out was that we need better models and more data. That's a given. The next point, the one that's highlighted, I think has already been covered, so I'm only going to just note that it's been covered. It's really hard to predict something when you're not really clear exactly what you're predicting. So deciding exactly what is flash drought, and Jordan Christian's climatology on flash drought should be really helpful here. And the very bottom line here that's also highlighted in yellow was one that we decided was also really important, and it really comes down to more computing power, being able to have longer hindcasts and more ensemble members. We go to the next slide. This is looking at what tools would create more value, and again, it just comes down to like having a really good forecast. That is where the value is made. That's a bit hand wavy, I acknowledge that. We could get a little more specific in things like, we thought that the ag community could get more value from really good 1 to 2 week forecasts based on the decisions that they make. And we also thought maybe more frequent updates of the forecasts that are already available would be useful. The last slide is looking at what are the things that we could leverage off of. Most of these have already been mentioned, so I'm not going to say them again. We're going to go on to the next group.
Great, thank you so much. So that wraps up the prediction groups, and we just have 2 more. You're stuck with me for planning A. So if you could go to the next slide, please. Oh, yeah, there we go. So focus in on the green points here. We had a small but mighty group for our planning discussion. And one of the first things that we talked about is the overarching idea that, you know, are the local response management actions different during a flash drought versus a conventional drought? But even more than that, we wanted to expand the question, the research question. Is it the speed of action that's required during flash drought that makes these actions different? So for instance, are you kind of forced to coordinate with different people because of the timing? Are you utilizing different resources because of the fact that flash drought came on so quickly? Another research question we thought is important, given the context of in the eastern part of the US, there is obviously a trend towards wetter conditions, and often that is what is on people's minds. So the question is, you know, are people assuming that flash droughts are less severe, less intense, and shorter because they come on fast? And that also ties into this, you know, the idea of cognitive bias, which is where the greatest importance is given to recent events. So if it's been very wet, how do they then interpret a flash drought coming into their area, and how does that affect things like declarations and actions that are taken? Next slide. In terms of tools that we think would create the most value, we had an idea for the communication, reflecting back to this idea that as people might not understand the overarching impacts of flash drought, and when it comes to planning and response, it's important to know that even if it intensifies quickly, there is a longer tail end to the drought, most likely, where the impacts will linger. So the idea of having a quantitative storyline of flash drought and its impacts, kind of a conceptual tool that we can use to communicate to planners and others that are responding to understand how flash drought doesn't just go away as quickly as it started in most cases. Next slide. And then current activities, the idea of this cognitive bias where it's been recently wet, and so maybe leveraging some tools that might be out there to address this. So for instance, in the Northeast during 2020, they've been using some different ways to show how, put in a historical context, even if they did receive rainfall, they are still below normal. And that's the graph on the right. One of the things that's been shown is that even though there is a spike of rainfall in October, they're still much below normal. So are there things like this that we could take examples of and leverage to communicate? And then the other activity, we did have a research question about how does the saltwater edge on coastal areas, how is that during flash drought? Investigate that a little bit more, and the leverage opportunity there is using the coastal salinity index that's been developed. And last but not least, we'll move on to the second planning group, and that is Viva.
Great, thanks. Just to provide some context to the group about who we had in our group, we had somebody with a strong background in agriculture, somebody with a background in multiple hazards. We were fortunate to have an emergency manager or somebody that represented that community in the group. So we were able to get a number of different perspectives on these 3 questions. I'm going to focus also on the highlighted yellow areas. So on the topic or on the question about where we thought the gaps and needs in research were around flash drought as it relates to planning, preparedness, mitigation, actions, and even communication. We focused in on 3 areas or 3 research topics. One was, and I think this has come up in other report outs, this issue of seasonality and geography. So really needing to get a handle for planning and preparedness purposes about how flash drought develops at different times of the year and within different parts of the country. And a specific desire to focus research on these questions for different sectors. There was some discussion about the fact that we need to look beyond just agriculture, which may be kind of from an optics standpoint, the sector that bears the brunt of these events, but the impacts are felt in other parts and other sectors of the economy. And even in sectors that don't maybe have a real or a quantifiable economic value, but nonetheless have extreme value to the other sectors, and that's in the environmental sector and the ecology and the habitats. Also thought that this was a fabulous idea. I thought this idea of research on the interplay between flash drought and other hazards. So the example that was raised by our emergency manager expert was this idea that when, especially around soil moisture or soils understanding and research in soils and the effect of flash drought on the soils, and in the context of a hazardous spill where an emergency manager will be trying to respond to and mitigate for hazardous spills, having an understanding of how soils are reacting to flash drought if that spill is happening at the same time. And this understanding the interplay in this context would help an emergency manager be able to make better, more productive decisions about how to mitigate for the hazardous spill if they understood how the soils were reacting to a flash drought. And then finally also this comment came from the emergency management expert, but was echoed by the other members of our team. This idea of being able to understand or have tools and products that give us greater insight on the likelihood of flash drought events happening. So putting essentially the decision making or arming the decision maker with more tools that help them to determine their risks and how they would respond to the risks. So having probabilities, tools that provide probability or likelihood of an event occurring. Next slide, please. So in the area of tools, what we thought would be some ideas for tools that would create value immediately would be tools, again, showing what are the probabilities of flash drought. I think that CPC is on the road to doing this, as was presented in the past couple of days. So maybe looking at how those tools shape out and seeing if we need additional tools after that. But looking at tools specifically at providing insight into the probability of flash drought versus conventional flash drought. Or conventional drought, sorry, considering in that tool development seasonality and geography. And then the other tool was this fabulous idea that was raised by our expert in a multitude of hazard areas, was this idea of developing a tool or a dashboard where a user, a planner specifically, somebody either at the state level or within a sector of the economy could toggle between different flash drought scenarios, different probabilities at different times of the year in different parts of the country that would provide impact data associated with those different scenarios that would help a planner to determine thresholds for action in a drought plan. Next slide, please. And then finally, the question regarding what's available, what's out there right now that could be leveraged to meet some of the ideas that we had for research as well as tool development. And we called out specifically, and this was identified by our agricultural expert on our team, that there was work that had been done through a partnership with the National Drought Mitigation Center and NIDIS around decision calendars, and maybe building upon that decision calendar research to better understand what critical times in the decision calendar among a multitude of sectors, not just agriculture, where flash drought could really have an impact, and really developing some additional tools and resources upon the existing research and tool development that's been done in this space. The other highlighted area, this was brought up by our emergency manager expert on our team, which is really leveraging the power of social media and ramping up communication efforts specifically targeted with state emergency managers as well as local emergency managers, really building those networks and those partnerships, using social media to get the word out about the probability of flash drought occurring in those regions. And that was it for our group.
Hey, thank you, Viva. Okay, so we have about 10 minutes or so. I wanted to open it up for some discussion. We heard a lot just now. A lot of ideas have been put out there throughout this session, and also, of course, throughout the rest of the workshop as well. And I do think we're starting to see some convergence of ideas and some big ideas rising to the top. But I wanted to spend these 10 minutes just to see if there's any other comments. I know that you could only participate in one topic. And so does anyone have any comments or reflections on what were said about the other topics or from the other groups in your topic that you wanted to bring out in the group discussion? And just a reminder that, oh, Mark, you are up.
Well, I just wanted to ask, I think sometimes there's just an assumption, a presumption, that NIDIS is going to be able to fund all this. And so I think, yeah, it's always the cop-out, right, resources. But to do a lot of these activities, I mean, I think it needs to be spread out amongst a lot of agencies and groups to fund this work, to keep it, to go R2O, research to operations, and maintain it. So I hope people aren't going to just think we can just dump this all on NIDIS and they can do it all, because their budget's pretty limited when you think about the task at hand. So I think this can't just happen out of thin air, right? It takes sustainable longitudinal work to make this sustainable, and especially with droughts, you know, that long period of record, the history, the impacts, you know, we're not even collecting that well enough. I just think there's so many gaps that we need the resources to do it and to maintain it.
I think that's a great point. And really quick, I was just going to say, as a reminder, you can raise your hand in the chat box by typing hand. And I do see, Richard, you have your hand raised. Or if you want to type your question in the comment box, that's fine too. But Richard Heim.
Yes, I found the discussion in, I think Viva's one of her points about having forecast tools that give you various scenarios of what drought might be happening. At NCEI through, I believe, a NIDIS funded activity, we've developed a couple tools where we take CPC forecasted temperature and precipitation and look at the various probabilities, the statistical forecast for the next 1 to 3 months, and determine what that equivalent precipitation and temperature value would be, feed it into the Palmer Drought program, and we compute a projected PHDI based upon warm and dry scenarios, wet and cool scenarios. And we also have another tool, I'm not sure if that's online yet, where we are looking at the current month using observed daily precipitation and temperature to the current day, and normal temperature and normal precipitation for the rest of the month to determine what the Palmer index would be at the end of the month, as well as normal temperatures and no precip for the rest of the month as a kind of a worst case scenario projection of the Palmer index. So there are a couple tools that are already developed along those lines. And I think developing additional tools using other indices and forecast tools would be a good idea.
Great, thank you, Richard. Matt Newman, you have your hand raised.
Yeah, this was something that came up in our group, which I just thought I would reiterate, which is that basically there are three components of the prediction problem. There's what you can predict, there's what you could predict, which is to say predictability, understanding the physical processes, understanding when some forecast scenarios may actually yield higher skill than others. And then finally, there's what's useful to predict. And you kind of want to set up your prediction problem with all three of those combined. And so what strikes me here in this discussion is that that's being split. That the monitoring aspect, the monitoring kind of measure of these flash droughts is not something that fits very well into the prediction problem. Whereas what we're typically focusing on predicting and doing predictability studies of is not perhaps the desired quantity, right? Because we're more focused on precipitation and temperature typically. And that, I think, listening to this for all 3 days, I think that disconnect has not gone away. Perhaps that's something that might be worth focusing on a little bit. Somehow, to do a predictability study, you're going to need to do long-term hindcasts, and so you need something quantifiable that you can test in 20 or 30 years of hindcasts. And it is worth mentioning, by the way, there that hindcasts, long hindcast records, not a year or two, but 20 or better 30 years or more, is essential because we bias correct all our climate forecasts. And we can't determine the bias until we have a large hindcast record. And we know that if we don't bias correct, we have much lower skill.
Yes, thank you very much for that great comment. Mutu?
Let me unmute myself. Thank you. Interesting discussion. I just want to add my 2 cents. I mean, when it comes to forecasts, I mean, the temperature and precipitation forecasts are the fundamental forecasts upon which many of these things depend on. And temperature and precipitation forecasts are actually variables, dynamic variables. And before CPC or anybody else makes these forecasts, we have actually such forecasts made by various models. And the forecasters use different objective, subjective tools to combine these various forecasts and issue them. But a drought is not a variable. Drought is a phenomenon. Drought is a hazard. And we have been discussing all these 3 days as to different indicators and so many different outlook capabilities, and many of which we don't even have observations of, many of them model derived. So to combine all of these, and of course that the drought monitor authors will know, if you look at all the indicators, there are many, and we are constructing many more. So a forecaster or a monitor author, how can he possibly comprehend and objectively combine them and come up with a forecaster? No matter what he comes up with, it's not going to be correct according to somebody else on the ground. So I think it's time that we come of age and we use the beyond the regression and the root mean square fitting, that kind of a simple algorithms to exploit these AI methods. What it does is it looks at the past data, the future forecasts, all those things in a very comprehensive way, much more than, and then begin to exploit those methods. And we are at CPC, we are beginning to work on that, and I'm sure other people are working. And who was it previously, Matt, who spoke, is correct. We have to test these on past scenarios by not only training the method, but actually making the actual forecast and how they have caught these things. And I think that that's kind of the way to go. But somebody subjectively combining these million predictors, indicators to do the thing is beyond comprehension, and saying that it can solve all problems is not likely.
Thank you. I think we have one more hand raised, and then we are getting pretty close to the end here. So Dennis, if you're able to keep it brief, that would be great.
You know I can keep it brief. This goes along with Mark's comment on resources. There's a limitation of resources, but it's not only money, it's people. Because as you're hearing all these things, we're talking about how we can improve forecasts. We need to do that, but we need more Tim Halls. We need more state climatologists. We need more people working in that intermediary area to make use of what exists already. Because no matter how good a forecast is, if people don't understand it, if people don't make use of it, it won't make any use. So we've got to have more people working in those boundary areas, helping end users be able to make use of this. Done.
Thank you. Okay, so really quick before we head into break, Kelvin, if you could bring up the slide with the polling, that would be great. 1 second here. So over this morning, last night, we have been compiling all of the great ideas that have come up that are potential actions, that are those gaps and needs that we could potentially fill in the various categories: monitoring, prediction, planning, and response. So over the next hour or so, we are going to ask you to please take a few minutes and go to menti.com. So the information is here on the screen, and you are going to put in that 7-digit code, and you'll be brought to a poll where we have put together these ideas. We've separated it into 3 separate polls: one on monitoring, one on prediction, and one on planning and response. And we have tried to do our best to reflect the actions that have been described, but this was obviously a pretty quick turnaround, so apologies if it appears as though there are some overlaps. And there's 12 options for each poll. So we did have to limit it a little bit to all of the great ideas, but those are not lost. We have a document that has all of the ideas. We just are polling on these specific 12 topics for each of those 3 areas. So we are going to be using the results of this poll at our very last session today, which starts at 3:10 Eastern, where we are going to start prioritizing some of these actions. So we are going to ask that you take this 10-minute break. Potentially would be a great time to do it. You also have through the next session until 3:10 Eastern to complete the poll. So we are going to go ahead and leave this slide up for the break. We are at another break at 10 minutes here. And so we will be returning to this main GoToMeeting room at 2:35 Eastern. So 10 minutes exactly from now to jump into a continuation of the discussion on the characteristics of flash drought. So we will see you back in 10 minutes. Right. Welcome back, everyone. Oh, hold on. It would be helpful if I put in my headset. Sorry about that. Welcome back, everyone. And we are going to jump into a group discussion. One quick note here, just reminder, the Menti poll will stay open until 3:10. We'll let you know when there's about 5 minutes left to finish it. But now I am actually going to turn it back over to Joel Lisenby, who is going to lead us through our discussion, continuing the discussion on the characteristics of flash drought. And then I believe, Marina, are you going to share your screen with the Google Doc?
Thanks, Molly. And I'll just wait for that Google Doc to come up, because the first thing that I wanted to say to start this discussion is to revisit some of the things that we talked about on day 1 about some of the key characteristics of flash drought. And so after day 1 finished, I went through some of the notes from our breakout groups, and I consolidated this list of what we said were the key characteristics of flash drought. And you'll see, I'm going to read through this, but just so you will note what my nomenclature here is, at the end of each line, I have an X number. So the very top line, rapid intensification, X8, that's times 8. That came up 8 times in the notes. So I kept track of how many times each thing came up to sort of get an idea of where most people were thinking, or what most people were thinking. This is a little small. Marina, can you zoom in on the page just a little more so that we can see the text just a little bit bigger? While I'm waiting for that, I'll start reading through this. So the most frequently mentioned characteristic of flash drought was rapid intensification, which was sometimes, but not necessarily at the onset. It could happen anytime throughout the drought. If it happened at the beginning, then that would be a rapid onset, and that's how I interpreted the comments around that. That came up 8 times throughout the notes from the 8 different groups, although some groups mentioned it more than once. The next one was rapid onset, and one group mentioned specifically that this was going from no drought to drought in a very short window. And as I was consolidating these notes, I interpreted anytime the word rapid onset came up, I sort of measured it against that definition that group brought up. And so that's just to be a little bit clear about where that rapid intensification versus rapid onset is a little different. The idea of short duration came up 4 times. Sorry, was somebody saying something? That's all right. The rapid onset came up 4 times. And then several groups suggested that key characteristics of flash drought should be defined by region, by sector, or by season. If we can scroll down just a little there, Marina. Is that all right? That's okay. I can just read from my own notes what we have. So the next is that flash drought should have some observed impacts or expected impacts that can be communicated. I think somebody mentioned on day 1 that if there weren't impacts, is it really a drought? I think that's a fair question. I think that could be debated, but I think it's fair enough in trying to decide what are the key characteristics. And the last 2, there was one mention of extreme heat coincident with precipitation deficits and one mention of elevated evapotranspiration. And if we go to page 2 of this, we're going to take some notes. The first question that I'd like to open a discussion to the whole floor is this. Has your perspective of flash drought changed over the last 3 days of discussion, today, yesterday, and Tuesday? And if so, I would like to know how. And if you would like to put your hand up, type hand into the chat box. And
I was sorry, Joel, just wanted to say, Marina, I don't see it even scrolling down. I know I see you in the document somewhere else. I don't know if it's easiest, I can try to share my screen and you can type.
Yeah, I am sharing screen, and I apologize. You're not getting any roll down at all?
No.
Nope, you're not getting any change. Okay, well, let me stop and let me just try it again if you don't mind. I apologize.
It's okay. This is giving all of us a really good opportunity to collect our thoughts about how has our perspective changed, if it has, over the course of the workshop.
Let me ask, is this working at all?
Yes, it is.
Totally.
Okay, good.
Well, apologies, everybody. I think we're set, Joel.
Okay. Yeah, I think we're ready to go. Would anybody mind sharing? Well, if your perspective hasn't changed, I guess that would be useful to know too. Because so far, I'm not getting any. Okay, Kyle says, I would say that mine has changed a little bit. I've learned how it can affect numerous different sectors in different ways, and there cannot be one solid definition that applies to all sectors. So thanks, Kyle. Thanks for sharing that. Mutu has put his hand up. Go ahead, Mutu. Has your perspective changed? If so, how?
Yeah, when I the first day when I listed the attributes of a flash drought, I put the rapid the rapid start first, and then the rapid intensification, and then the duration. That's the kind of order I envisioned, but listening to 3 days, I think it looks like the rapid intensification part kept coming up more. And now that Joel, you suggested that in fact even the rapid onset could be a form of intensification. So in that sense, my understanding of this has changed a little bit. So intensification, rapid intensification, rapid onset, and then the duration. I mean, those three seem to be the essential fundamental characters. But how exactly over, how intensify over what period of time, by how many categories, and those things and all, we need to address the finer details when we have to come up with the definition. So that's all.
Okay, thanks for that perspective. Han says she's a bit confused with the distinction between rapid intensification and rapid onset. Aren't they the same? So I think that's a really good question. And maybe I'll give you what my perspective was as I was reading through everybody's notes. And that was that you could have rapid intensification at any time during a drought. So you could go from already in drought period, you could be already in a drought and then it intensifies quickly to even a worse drought, whereas the onset comes at the beginning. I think I would like to open this up to others who may share a different perspective than I did when I was looking through the notes to help clarify that. And maybe we can have that discussion in the chat box if you would like, if anybody would like to respond to Han. Michael Brady, you have your hand up.
Yeah, can you hear me?
Yes, I can.
Okay, great. So yeah, my perception of what a flash drought has changed. I'm probably out of the 4 that you put for duration. Maybe I have 3 of those. I felt strongly with, and I'm thinking in layman terms, how I associate the word flash. Like I've used examples: flash mob, flash fire, flash flood. But that rapid intensification, like you said, if you're looking at this like on a line graph and you just see that ramp up, that helps me see that this is slightly different than what I had originally viewed it as. So it's changed a bit, and this has been very informative for me. So thank you very much.
Yeah, good. Thank you for that, Michael. The next hand came up from Dan.
Yes, hello everyone. Can you hear me, Joel?
I sure can, Dan, go ahead.
Great. Yeah, I think my perspective that, I don't know if it changed, but it kind of opened my eyes a bit to it, is the need to kind of unify the monitoring and predictions of flash droughts, that there's a pretty big gap and disconnect between what's available and what we need to kind of advance the prediction, and then I guess the early warning. And so yeah, that kind of just opened my eyes a bit and gave me a new perspective on thinking about how to kind of merge those two or unify the two a bit more as we move forward.
Yeah, great point there, Dan. I think that when we're looking at activities that can add value in this space, there are some that would make both monitoring and prediction go easier and help us understand better what's happening. So thanks for that point. The next hand looks like is from Laura Edwards.
Yep. Hi, Joel.
Hi, go ahead.
So yeah, I think this conversation over the last couple of days really kind of opened my eyes to this distinction between intensification and onset, as others have indicated. Walking into this workshop 2 days ago, I really felt it was onset, rapid onset exclusively, and I really considered the intensification part while you're in drought. But I'm open to considering that, and I'm still kind of pondering that. Over the course of the last couple of days, I did a quick little social science poll of my own in the office here and asked some non-climatologists, non-modelers, what they thought about the definition of flash drought, what they thought that meant to them. and they just thought like a quick, like come up quick. And they felt that the term flash drought didn't tell them anything about duration, which is different than what I thought. I would think it'd be come on quick and go away quick, but that's not what they said. So it's really, I guess, got me to thinking a little bit more about what my audience and my clientele might define these words as being, which is a little different than what we're hearing here today in some sense.
Yeah, that's great, Laura. And thanks for taking a very official poll of your your workmates to give us an idea of how people are interpreting the word. I'm just going to have a quick look through if there have been any other hands pop up. I don't see any more, but I think I might add, so Marina is taking notes here where everyone can see. And if you think that she is not capturing your thought correctly, go ahead and speak up, and she can make that correction. I think it'll help us in the end to make sure that we're correct. We've talked about how our perspectives might have changed. What about one of the objectives of this workshop was to strive toward consensus on flash drought characteristics. We use the word strive there on purpose because with a room full of so many differing opinions, it's unlikely that we'll actually reach a consensus. But I'd like to know, one, if you think we're getting closer to maybe corralling in this concept of flash drought, what it really is, and are we, I'm trying to think, I'm trying to place the right words. Are we getting closer to understanding better this word flash drought and what it means? And if not, is there more discussion that we can have? We've got a few minutes now. Is there more that people want to say about this to help us accomplish that? Viva put her hand up right away. I'd like to give you some time, Viva. Go ahead.
Yeah, and it kind of goes a little bit with the first question you asked. I guess I would say that I feel, at least in the conversations that I participated in the breakouts, that organically, without me providing it as a context to the discussion, people were just conversing about flash drought using the characteristics of rapid onset and rapid intensification. Where I didn't hear a lot of conversation was about this idea of defining it, or a characteristic being short duration. And I wonder if it's because that short duration component is so tied to the impact question, whether or not, number one, you have to be able to look back. I guess when you're in a flash drought, you can't really know how long it's going to last. And so you only have the ability of hindsight to really tell you how short it was. But also that maybe the short duration, being able to establish what that time frame is definitively, whether it be a month or 6 months or whatever, is really predicated to some extent by the impacts and how quick the impacts cascade one on top of the other, or how accelerated the impacts are that we normally would feel in a conventional drought. So I don't know if that makes sense, but that's what I was able to glean from the breakout groups that I was a part of.
Great, thanks for that, Viva. I've got two more hands. We'll go in this order, first with Michael Brady and then with Han. Go ahead, Michael, you there?
Oh, okay. So yeah, I was starting to type mine. I was just going to type it, but I just it's been my observation that there's different presentations that have been put on here where it's presented as if the definition is already there, and then there's others that question the definition. And there's been a lot of conflicting information, I guess, like, and it's the whole conference has been great. Don't get me wrong. I just feel like this should really be defined before trying to figure out what you need and how to best put that information out and all that type of stuff. I just feel like there was no common agreement on the definition, which needed to be there even before this, the rest of the stuff was discussed.
Okay, fair point. So you're saying that maybe we didn't quite land that first step before we moved on to the second and third steps. And I don't know if I would disagree with you on that.
I think
Han,
it's great information that's come up for sure, but yeah, that's where I.
Great, thanks for that. And Han, are you there?
Yeah, I'm here. So from the feedback about on the answer people are giving, so now my feeling is like we have two definitions and two different things. If you look at the rapid onset, then you look at any type of drought, because you would go from no drought to drought. So you don't look at the duration of drought. Any drought can be a flash drought as long as it has a rapid onset. But if you look at the rapid intensification, then it could be any type of extreme drought. So you might be in drought, and then you become an intense drought very, very rapidly. So you're looking at a extreme part of that drought. Does it make sense?
Yes, I think let me say back what I think you're saying, and that is that it seems like we've got two different things happening that we're calling both of them a flash drought. One is the rapid intensification that may happen anytime during a drought. So if you're already in drought and it gets worse. And the second one is when the drought begins really rapidly. You go from a no drought situation to a drought situation. And I think your main point you're making is that these are two different things, and maybe we should have two different terms for them. Am I understanding correctly what you're saying?
Yeah.
Okay. I'd be interested in what other people have to say about that. Jason has his hand up. Jason, maybe I'll let you say what you were going to say, and I also assume you would have something to say about what Han just brought up too. Go ahead.
Yeah. I can actually speak on both her and what Viva was saying too. I personally prefer rapid intensification because I think of onset as a single point in time. So either you have drought or you don't. So that becomes a point in time, and that can be a point during the rapid intensification. And rapid intensification allows you to generalize to where it can now mean that onset point, or it can mean intensification later in the drought event. So I think it's a more generalized term that's just I don't know, it's just what I prefer to use. And I think with what Viva was saying, I think that it would be very good, or that we should put a minimum duration on a flash drought. So you must assume that the rapid intensification lasts for a sufficient amount of time to make it not just be another synoptic weather feature. So perhaps that means it should be at least 3 weeks or 4 weeks or something of that sustained rapid intensification. But beyond that, it should be able to last as long as it takes. Because if it stops at a month, fine. But if it lasts for 2 weeks, you shouldn't put some kind of arbitrary limit on it. So it should really be able to account for the amount of intensification and also how long that intensification is.
Great, thanks for that, Jason. Now there are a lot of comments in the chat box, and if you're not following them, there's a lot to catch up there, and I won't be able to keep up on all of them. Although as I've been reading, I think some are really good points. I'd like to point out Mike Hobbins' comment that what about a flash drought versus an embedded flash drought as two different terms. Now I've got a few hands up. I'm going to let Viva go first, and then it looks like Mutu and then Mark.
Yeah, I was just getting ready to type. I agree. Thank you, Jason, for providing that additional insight to my comment. I agree with you. But I also agree with the point with you and Gwen, because it looks like Gwen is agreeing with you too, Jason, on the rapid intensification. As I think about it more, and as I was listening to the speaker, to the folks talking about rapid onset, if you were just for a moment to take the drought monitor by itself as an indicator of drought by itself, rapid onset could look like going from nothing, not even D0, to like a D3. And I don't think that would ever, I don't see an instance where that would necessarily happen. So you're right. I think the focus or the primary characteristic in characterizing flash droughts would be that rapid intensification once the drought has been identified or called, if that makes sense. Thanks.
Okay, thanks, Viva. The next hand was Mutu.
Yeah, I mean, the more I hear the comments before, I am getting a little confused now with the role of intensification because of this scenario. For example, what if you are in a D0 and then it quickly intensifies to D1 and then stays there in D1 for a long time? Let's on the whole drought lasting over a long period of time. Do we call this, because of that rapid intensification, do we call that a flash drought? So the more I think about it, I think if we need to ever, if we have to, set up with a definition of flash drought from other droughts, we have to, of course, the rapid onset part is always there. I mean, that's why the flash thing. So the rapid onset, and then we have to, I think this is my opinion, that of course the rapid intensification is there also, but then the whole thing has to be lasting a certain period of time, and what that is we have to come up with. So I think that's kind of what I feel. If in between some categories it intensifies rapidly and stays there for long, that is become a more long-term drought than the in between rapid intensification part of it. So I hope I made my point.
Okay, thank you, Mutu. There was one other hand, it was Mark. Go ahead, Mark.
Yeah, thank you, Joel. Yeah, a lot of great comments. Obviously, heard a lot more interesting takes to me coming into it on the intensification side, because intensification can occur from a non-drought state, of course, into a more intense severity level, or perhaps, as we've discussed, between this current state of drought to a more severe state of drought. I think one of the issues with that as an only definition, I think the bottom line to me is, just like drought, we have 200 definitions of drought. I didn't come into this expecting I was going to come out, or we were as a group going to have a consensus to one drought, flash drought definition. So I don't know why it can't be explored in both aspects of intensification and onset. The reason initially that I used that terminology, however, let me go back to Stu's comment about impacts, is if you're already in drought, you're already going to have some impacts in play. So the awareness should be there. The problem I had with going from a non-state drought, 0, D nada, whatever, into something more severe over just a few set of weeks was for the awareness, the education, the communication of drought as a hazard, and how that plays into triggers and decision-making and eventually policy-making. So to me, that's where onset's more critical, because you're starting from no drought to not keep sticking your head in the sand and responding to the drought. If you're already in drought, you should already have some of those measures in place. So that's why I think there's a distinct difference between them as I see it. Thanks.
Yeah, thank you, Mark. Matt, your hand is up.
Yeah, I guess I got to say, after 3 days, I may be more confused now than I was before.
Oh, no.
I put it in the chat box, but just to kind of reiterate, I guess a question for me is whether flash drought is basically a phenomenon or not. If it is, for example, a drought that develops very rapidly and lasts on the order of, subseasonal to a seasonal timescale due to kind of a surface feedback, say, then that would be, you could consider that a phenomenon. That would be a particular event one could sort of study. If you define it in terms of variability, then it becomes more arbitrary, right? If I think in terms of blocking, for example, I can define a block as a phenomenon because it has some sort of discrete, say, well, this gets meteorological, but vorticity signature. But when I start talking about heat waves, I can get kind of very vague because they can last for any length of time. I can have them be any intensity I want, right? What threshold is a heat wave? Is 90 degrees a heat wave? Is 95? Is 100? Does it have to be 10 days? Does it have to be 20 days? This becomes just basically, in a system which has a certain kind of variability, you're just arbitrarily picking a tail. I don't have an answer for this. I don't have a sense yet which category flash droughts falls into, but I think that might help kind of guide the way one makes these choices in this sort of definition.
I think that's a great point. Like, where is it, like, where do you draw the line to be able to define flash drought as a thing? And it's almost like asking how long is a piece of string, right? So we have about 3 minutes left on the agenda for this discussion. So this would be a good time if anybody has any last minute thoughts that you would like to share, to put your hand up. I'm really having a hard time keeping up both with the conversation on the chat box and what's being said. But if anybody would like to share your last minute thoughts about how flash drought should be defined, or at least the guiding principles, we'd love to hear that. Imatais, I probably said your name terribly wrong, and I'm sorry, but your hand is up.
It's Imtiaz.
Wow, I was way off. I'm sorry. Go ahead.
Not a problem. I would like to agree with Matt on kind of treating flash drought as a phenomena, as an event, because I, again, would like to bring the analogy of flash flood. You know, you can have a flash flood event within a wet period, but that event is really, you know, what's really driving those events is like a high intensity precip phenomena. And I think in flash drought, I imagine there's a high intensity land surface feedback phenomena that's happening. And so for me, that would give it a real physical meaning, because that has real impacts, that the phenomena driving impacts.
Great, thanks for that comment. This is going to be our, so we got two last ones. So Michael Brady will give a comment, and then Jason Atkins, you'll have the last comment for the session, and then we'll wrap it up. Thank you.
Yeah, I'm going to be very brief. I just wanted to reiterate that we need to make this terminology useful to the end user, and this needs to be a collaborative effort. So really, I don't think this is going to get fixed out right here, but you need to work with decision makers, contact them through social media, whatever you need to do, but that communication's got to start. So that's it.
Great, thank you, Michael. And Jason, wrap us up.
Yeah, I was just going to say that I think it's important to keep flash drought in the perspective of as part of a continuum, you know, where intensification can be everything from something really small to something really big. And we need to define where that break point is between, you know, quote unquote, regular intensification and rapid intensification. And I really think that the closest parallel is what they do with hurricanes, where, you know, obviously all hurricanes have to intensify to become hurricanes, but some of them intensify more rapidly. And that's given the, you know, the nomenclature rapid intensification. It's rapid intensification hurricanes. And even there, you know, there's a discussion about, well, when does it become rapid? You know, when is it actually different than normal intensification? But there's still the awareness that it's important. It's important to be able to document when rapid intensification happens and what are the processes that go into making it. So it's really important to be able to, you know, still do the research to try to understand why flash droughts are actually happening.
Great. So keep in mind that it could happen anywhere along a continuum. Thanks for that comment, Jason. I'm going to draw a line under the discussion there. I'm going to pass back to Molly to give us instructions on what's next.
Thank you. If you could share the next slide, slide 16, please. That was a great discussion. Almost hate to cut it off to move on because there is so much great information that everyone was saying. But we are going to move on to our last session here. We only have about, I don't know, about, let's see, 35 minutes left or so. But just a last call to please fill out the poll. We have about 5 minutes until we'll close it. And the information to get to the poll is on the screen again. But at this point, I'm going to turn it over to Viva for just a couple of minutes to talk about kind of the objective of the next session to establish some next steps. So go ahead, Viva.
Thanks, Molly. So I too was really energized by this last set of discussions. I want to encourage us, those of us who maybe expressed feelings of like, now I'm more lost than I was before, hang in there. There is, I think that we're really just spending the time necessary and analyzing this from so many different angles. And this often happens, I'm sure everybody has experience when you're getting into the weeds of things. Sometimes it can get a little bit confusing, but I am still optimistic that we are starting to develop a clear path forward. And that's what I'm going to tee up for our last bit of time together. Really happy to see that we've retained a lot of the folks throughout the rest of this, throughout the day. And like Molly said, we have a few minutes, well, relatively few minutes left to go here. We're going to spend the next 35 minutes, I think, diving into what the results from the Mentimeter poll showed us. Collectively, where we are all coming at some of these issues in terms of priorities as a community moving forward. And I want to stress community because that was something that Mark Svoboda brought up initially, which is, yes, NIDIS, this is something that NIDIS is expected to tackle through its public law mandates, but it is a relatively small pot of money, and it would go a lot further if we could leverage it with this community that's on this call and has been participating in the workshop. So what are we going to spend our time over the next 30 minutes talking about as we wrap up this 3-day workshop? Some of the questions that we'd like to tease out with the remaining time is, what do we collectively as this community want to accomplish on flash drought? What does success look like? This has been a very big issue for stakeholders and users like Mike Brady on the ground. And Mike, I want to say to you that we have every intention of convening a group of users, the user community. We'd like to be able to kind of get our act together around some of these technical kind of research scientific questions. And the goal was to come to the user community a little bit more organized, because as you can see that inviting the user community in this discussion, I think, might have complicated things, but we are going to be coming to the user community with this discussion and look forward to bringing you, Mike Brady, and others into helping us design what that workshop would look like. So what does success look like coming out of this workshop? What steps do we need to take collectively in order to meet that measure of success, to be successful? And finally, because NIDIS has a role to play in this, we'd like to, as a program, NIDIS, which, as you know, is an interagency program, and it's not just a group of 9 or 12 people that make up the program, but what is NIDIS's role collectively and our partners' role in supporting the ideas that come out that would really lead us to success? There will be a report that's going to come out of this, and we'd like to make sure that this report clearly defines what success looks like and kind of lays out a path forward. So with that, I'm going to turn it back over to Molly. Hopefully you all have been able to participate in the Mentimeter poll, and Molly's going to walk us through some of the things that we've learned from the Mentimeter poll. So Molly, take it away.
Great, thank you. Okay, so I am going to share my screen here. Let me make sure I'm sharing the right one. Okay. Let me get these in present mode. So I believe Marina is likely Oops, I think it started on planning. Hold on 1 second, sorry. Let me start with monitoring here. Voting is closed and we've had a good number of responses come in. So just briefly, we're going to go over and focus on some of the top selections based on the poll. And then after we take this information, we have a little exercise we're going to do on what's called a Jamboard. It's kind of like a virtual sticky note where we are going to prioritize these activities. So first, looking at monitoring, the top activity that came out in the poll is to identify standards for flash drought. For example, key thresholds, rate of change. So that, I can't see how many people voted, I don't believe, with this screen, but we can once we go back to look at the information. The second most popular, identify key indicators of flash drought and which lead to impacts. So I think the idea behind this one especially was, you know, taking out some of the other indicators that are used for conventional drought that maybe could create some noise when trying to identify if it's a flash drought or not. The third, produce a climatology of flash droughts across the country. It was a very popular choice. And just to clarify, Han, thank you. So 66 is the total number of people. I just was saying I don't know exactly how many are within each of these categories, but we do have that data. The fourth, increase in situ and satellite monitoring, soil moisture stream flow, identify flash drought impacts by region and type. And then the sixth, because we are taking the top 6, would be the research on the compounding and cascading impacts of flash drought. And again, we will make all of these results available for everyone after the workshop. So moving on to the prediction poll, the top activity is the prediction of flash drought, including extreme heat and low precip at weeks to months lead time. I think that's always one that comes up and a great one that obviously came out top on the list. Advanced land surface models, high resolution and with dynamic vegetation. That's almost tied with the developing of the integrative indices for forecasts, same as used by monitoring communities. So that came up a few times as well, of that connection that we need to make. Research, are there limits on the predictability of flash drought? Better understanding the new predictability resources. And then finally, the top 6, number 6, is how long do rapid onset droughts typically last? So to have that data to kind of help us communicate and understand the prediction. I'm sorry, to understand the duration. Finally, looking at planning and response, the top activity is to identify triggers that give managers adequate lead time to address a flash drought. Second, provide prediction and projections by sector. Research topic is to respond, or do you respond in a flash drought differently than during a conventional drought? The fourth response, top response, is to identify and develop tools for both statewide and more local or sector-based responses. The fifth, the idea to have a quantitative storyline of flash drought and its impacts to help communicate. And then finally, the sixth is to research the best practices on communicating flash drought implications to broad audiences. So I am going to exit out of here. And while I was doing that, I believe that Joel was helping us populate this Jamboard, is what it's called. Okay. So, Joel, I wonder, are you still trying to get to our top 6 here?
Yeah, I was not quite as fast as you were reading through it. And the first time I saw the results were when you were reading through it too. So I was, I was just a little slow. So I have, did I just lose it? Okay, sorry. I minimized GoToMeeting and I lost everything. So can you go back to the monitoring results?
Yes.
Okay, so I was trying to pull them aside as you were saying them. We've got identifying, could you read the top 6 just quickly again?
Yep, I was just going to try to make it larger. Okay. Identify standards for flash drought.
Okay, so that's number 1.
Identify key indicators of flash drought, which lead to impact.
2.
Produce the climatology.
3.
Increase in situ and satellite monitoring.
All right, that's number 4.
Identify flash drought impacts by region and type.
Yep, that one's that, and then the rest I can move aside. So I've got the 6th there. In that order, I think I got all of those, and then the last one that I missed was from the planning and preparedness.
Okay.
I think I missed the 5th or 6th one.
Okay, so quantitative storyline of flash drought and its impacts. And research best practices on communicating flash drought implications.
Okay, so all the other ones I'm just going to park to the side.
And you can go ahead and delete them.
I can just delete them? You don't need them?
Just go ahead and delete them to make it a little bit cleaner.
1, 2, 3, 4, 5, 6. Okay, I got all of those down here. Oops.
Sorry, apologies for the on the fly here.
I'm a little slow. That's okay.
No, you're not slow.
Okay, so our Jamboard's ready, and we already have these somewhat listed in the order that they showed up.
Okay, and I am just going to try to enlarge some of these. So what we are doing here, you will see on this Jamboard, we have, Joel, if you wouldn't mind making some of those bigger while I talk about the
yeah, sure.
how it's laid out. So the blue sticky notes are monitoring, yellow is prediction, and green is planning. And what we have here is a board where we are going to move these around, showing us the importance on the left, so low importance to high importance, relative to one another. We all know that these are our top 6. So I think understanding that this is relative to one another versus the bottom axis, which shows easy to the left and hard to the right. So essentially, in the end, we'll be able to prioritize and see the ones that are highest priority, but also understand that, of course, not everything is easy. Actually, probably none of this is going to be easy. But we just want to see if we can sort this out in this way. So why don't we go ahead and start with the monitoring, the blue. So here we have them. Hopefully, they're large enough for people to read. But if anyone wants to go ahead and make a comment on any of these monitoring activities in blue, I can start moving them around, and feel free to comment in the chat box as well. And if you'd like to speak, go ahead and raise your hand or type hand in the chat box. Hand Art Dicatano.
I guess I have to also unmute. I'll start with the easy one. I think the identify standards for flash drought has got to be high importance. That seems like what we've talked about for the last 3 days. However, I guess over the last 3 days, I would have changed my easy to hard. I would have thought that was easy, but I think as time has gone on, that's probably harder because there's a lot of different opinions. I might go, kind of like, yeah, maybe middle of the road for the hardness. I mean, I think it'd just be a matter of really the meetings of the mind. Maybe the stakeholders would come into play there in terms of, what is really important. So I think you have it in a good spot.
Okay, great. Mike Hobbins.
Yeah, I think some of them have to precede others. I don't know whether that places them higher or lower on the importance scale, or the ease.
I'd say
scale.
higher. Yeah.
So I think so what I'm particularly thinking of is identify which key indicators are the key indicators of flash drought. Has to precede developing the climatology, as does identifying standards for flash drought.
Okay.
Well, no, okay. The climatology can't be developed until we've identified the standards. So the one that's in the crosshairs has to be after the one that's top right, that one where your cursor is right now. And some of them can of course, run in parallel, like increasing the in situ and remote sense monitoring. Yeah, and so the compounding and cascading impacts of flash droughts, you can't do that until you have until you know how to define flash droughts, and then what is your population of flash droughts. So that also has to go behind the climatology. So there's an ordering too, basically.
Yeah, I would just not separate. I agree 100% with Mike, but I saw you like move those others down in importance. My opinion is they're still important, but the ease maybe is the sequence.
Okay.
Yeah, it's an XY.
Okay.
An X-axis question.
Yeah. So in terms of ease, I don't know if, like you said, we need the key indicators. If these three maybe should just kind of stay right in here. Let's see. We also have the increasing in situ and remotely sensed monitoring. I know that is important, and we're getting there. It's not easy, but I'm wondering if where that one should go. Does anyone have any thoughts? Let's see, Pete Goebel, let's see. I would argue increasing in situ and remote sense monitoring is both hard and high importance. Yeah, that is a good point. It is. Peter, would you like to go ahead?
Yeah.
Oh, I just put hand in case you didn't get to that comment, but yeah, just reiterating what I wrote in the chat that, increasing our monitoring is never easy, and especially maintaining additional monitoring is never easy. But I think that it has benefits far beyond flash drought, and it has benefits towards identifying flash drought. So I would put it at high importance.
Okay. In terms of the research on compounding and cascading impacts of flash drought, where is this importance on the relative importance scale to, for instance, identifying the key indicators, producing the climatology? Is it a little bit lower because we need to get those first? What are some thoughts on that? Okay, Brian. Okay, any thoughts on the research of cascading impacts, also identifying flash drought impacts by region and type? Again, that has to come after all of these. It's still important.
So we had a few hands go up. We've got Jason, and then Trent, and then Viva. And I almost wonder if where we're all looking at the Jamboard and we're not all following the chat box, I think it'd be okay during the session if you just want to unmute yourself and speak up. I think that might make things go a little bit quicker.
Okay, that sounds good to me.
But we'll still go to Jason first, and then Trent, and then Viva.
Okay, I guess my preference would be to make the identify standards for flash drought a little bit higher priority, because that's the linchpin for all of this. But then a lot of the rest of them, they're all kind of chicken and egg type things here, where I think that they're actually all of equal importance, because part of the idea of producing a climatology is to get an idea on which of those indicators are actually useful. Well, that in turn right away is also getting to looking at the impacts by region. It's looking at the compounding and cascading impacts. So it's a very circular argument here about which of those four are more important. I think the identify standards, though, has to be the most important one, because otherwise you can't do the rest. But otherwise, it's kind of a mixed bag, I guess, and which is most important. Yes, as Jeff was saying, iteration is important.
Yeah, Trent.
Yeah, Jason actually just said what I was going to say. He stole it from me, so I'll just steal his idea. I think the identifying regional impacts should though come before the identifying the indicators, because the indicators are supposed to be leading to the impacts. Got to know what they're indicating before we identify them.
Okay. Yes, and we also are capturing this in notes just so everyone knows, in case my boxes are not matching up. Okay, Viva, your hand's raised. We probably do need to move on to prediction, but Viva, do you have a comment about this?
No, I'll pass. Thank you.
Okay. Oh, Joel, we're moving in the same one.
Yeah, we are. So I don't know if it matters, but I had ranked these in the order that they showed up in the poll already.
Okay.
I don't know if that matters though, as we're moving things around.
Yeah, great. Okay, so moving on to prediction. So then that top one would have been prediction of flash drought at weeks to months lead time. I think this one always comes up. It's a high importance, and I would also guess a high difficulty. Any disagreement on that? Again, as Joel said, feel free just to speak up if you would like. I will take no voices as an answer. Oh, did you have a?
No, I was just sort of chuckling that nobody said anything. I think that you've landed a pretty good spot there.
Okay, advanced land surface models, high resolution with dynamic vegetation. Also developing integrative indices for forecasts, same as used by monitoring community. I will leave it with those two for now. Hyland.
Hi, can you hear me?
Yes.
Yeah, I just want to say that I pretty much agree about the level of importance for the item number 1. And also it's really difficult, but regardless how difficult it is, this is a way to go, yeah, if we want to address the user needs. And also regarding the second item, I think I have mentioned this twice today, but here I'm just going to say this again. So basically for the development and production of flash drought forecast products, we at CBC, we will need to have more advanced land surface models. So currently we do have land surface models at CBC, but these are just in general pretty old. So we just look forward to some collaboration opportunity to get this done. And I think regarding second item, it could be potentially a low-hanging fruit because if there are already such land surface models available, and if there are some channels, you know, for this collaboration between CBC and the folks who can provide such land surface model, I think this could be something that can easily done.
Okay.
And I also want to mention that making these land surface models available to CBC the benefit can go beyond the flash drought prediction. It can just can be applied to the general drought prediction for the lead time of monthly and beyond. It can also help us advance the drought monitoring capability.
Thank you. And I did move it over a little bit to the easier side, but still important. And any comments on that or any of the other prediction ideas? So the others are research. Are there limits on the predictability? How long do rapid onset droughts last? And research into new predictability sources.
Hey, Molly, it's Andy. I think all those the research topics can be lumped together. And the reason why I say this and advocate for being put as a hard thing, but also in high importance, is because you can't predict something you don't understand. So we can create all these products, but if we don't understand how they work and whether there's any value to them, then what's the point?
Mm-hmm.
I guess
go ahead.
I would just say that the last one that you have is basically in its way the same as identify standards for flash drought. So those, as I was basically kind of saying before, they kind of go hand in hand. They're essentially two sides of the same coin. I could probably run through a bunch more trite sayings, but you get the idea.
Yeah. Any other thoughts on the prediction? I grouped these together, and I don't know if they need to be adjusted in terms of importance or ease to difficulty.
Molly, one thing I don't see is, this is Doug, and I missed a lot of this call today. I had to be on another one. But anyway, so if it's already been said and disqualified, just throw me out. But is part of the prediction, part of prediction is the communication part in understanding antecedent conditions. So my question is, and it's not a hard one. I don't think this is hard. I just think it's in terms of difficulty, but I do think the importance is high, is that communication of our current conditions based on what has happened antecedent conditions, if you will, and the likelihood or how we're set up for a flash drought. To me, that's half of the prediction battle right there. That's the warning, if you will, without any outlooks at all. Then you can throw the outlooks on there, or you know, the research. But I don't know if that fits into this conversation or it fits in somewhere else.
Yeah, no, thank you, Doug. I think that's a really good point. And it has come up in some sense, at least I know in a breakout group that I was involved in. But I think that point is definitely will be noted. We are taking notes outside of this. This was kind of the results of a polling, but that is a great idea and something that we will definitely take note of. Any comments on that, or other comments on the predictability sticky notes? Lower right corner. Mark, way to get us at least something in the lower right corner. Yes. Okay. So in the interest of time, we are going to go on to our last with planning. So if I recall, the top idea here, it was to identify triggers that give managers adequate lead time to address a flash drought, and providing prediction projections by sector. So I will start with those two. Any comments on one of these top two ideas?
Molly, I think that first one, identify triggers that give managers adequate lead. I think that certainly belongs somewhere in the upper left quadrant.
Okay. Do you think in terms, I agree, and with the importance in terms of the ease, I mean, I know that some of this, the blue sticky notes will need to come before, so maybe it's somewhere in this area as well.
Yeah.
The second one on the sectors, I think gets grouped with the impacts in general and can even contribute to it. I think in our breakout group, we were saying, you know, there's probably a PhD dissertation or two that could do a lot on this and really jump us forward on some of those impacts, you know, differences by sector, differences by region. And it's a little bit of investment in resources, but it's not that hard in terms of the scientific question.
Okay. So maybe somewhere a little bit on the easier side here.
Yeah.
Okay. What about the research question of, is response different during a flash drought versus a conventional drought? There's also the research question of the best practices on communicating flash drought implications to broad audiences. Mark, go ahead.
So I think one of the challenges here is what we've heard, and I think this is reaffirmed by the practitioners that joined us here this week. Do they know, you know, this isn't, I don't think this is a term or concept that's out there in the lay public, sort of. You know, it's not even really used within the concept of the drought monitor, which is widely disseminated, right? But in this case, if it's not in front of them, I think there'd be a ton of education up front to even start to understand what is implemented during a regular drought versus a flash drought, because they probably haven't even heard of flash drought. So I think that awareness education piece isn't hard, but it's, you know, it's pretty important. So it sits right there on between the top right or right, almost in the convergence of several of these boxes. So I just think that not enough of that community probably is even aware of what it is. And of course, we don't even have it figured out between the people working in the field. Thanks.
Thank you. Any others that are more on the user side, the planning side, that are on the call? It looks like, Brian, you said you're withdrawing. Okay, what Mark was saying. Anyone else on more of the user side that might be responding or planning to drought have any thoughts on, you know, the research into how responding is different, or this communication piece. I guess this was also another one of the quantitative storyline of flash drought and its impacts. Michael Brady, I would suggest repolling after definition is agreed upon, especially in regards to planning. It's hard to set the oven by ingredients if we don't know what kind of size or cake is being made. Yes, that is a good point, and one that we'll definitely take for sure.
I'm going to chime in real quick, Molly. I think that has to be relatively high, because I think if the response isn't different, doesn't that kind of in some ways factor into those definitions and things like that that are in blue that are kind of hidden up there? So I don't know if that's where you were putting it, but I might argue that's higher in the importance category, because if we come up with a definition, but nobody uses it, or is this not important for anybody in making decisions? I don't know. I can't think of a good cake analogy, but
yeah, and I think that's a great point, and something that did come up on Tuesday as well, of if it doesn't really matter to the end user, why do we, is there a point for us to do this definition outside of the research capacity? Oh, let's see. Oh, Brian, I think your sound is off. I don't hear you. Well, I hear you, but it's mouse-like, which I know we've had issues with before. Okay, sorry about that, Brian. Feel free to type in. He agrees with Art. Yeah, I think that's a very good point. Okay, so we are getting close to the end. I can see I didn't do a very good job of doing relative. I was hesitant to put anything that was a low priority or low importance. So, but I think everything is obviously very important. Mark, yes, and I think that is true, Mark, that it makes sense that these are all in the top because they were polled the highest. So it would have been great to do this exercise, and we do have that data of what was polled as well, so we can take that into consideration. Are there any last comments on the Jamboard before we wrap it up for the workshop? I like the cake reference, Peter. You should put cakewalk in the lower left corner for a frame of reference, yes. Okay. Hearing none, I am going to stop sharing, and then if we could pull up slide 17, I'm going to turn it over to Viva for some closing remarks to wrap us up here.
Great, thanks, Molly. It's been a great 3 days. I want to basically say once again, thank you to all of the attendees who were able to join us for any part of this workshop or the entire 3 days, including all of the breakout sessions. It's very common for people, especially in virtual environments, to kind of duck out for a little while during breakouts, but most of you stuck it out, and we can't thank you enough. As you can tell, we really we think that this discussion, the report that will come out of it, will help inform a number of different organizations, states, government, federal agencies, local organizations to kind of take the torch and move forward on some of these priorities. So thank you again to the attendees. I wanted to say a couple of extra thank yous to a couple of folks and groups. First of all, the planning team. You all have become familiar with Molly and Joel and Marina, and I want to say thank you to those 3 NIDIS team members who really spent quite a bit of time thoughtfully thinking about how to organize this workshop in a way that would bring value and benefit to the attendees. So thank you to those 3 NIDIS team members. I want to say a big thank you to the AV and the technical help that we got from UCAR, as well as from Allegiant, and specifically to Brian, to Tammy, and to Kelvin. I want to thank the facilitators, the moderators, and the note takers. Without you, we wouldn't have anything that we could all kind of hang our hats on and move forward with a set of priorities. And then a big thank you to our advisory group. And I'm going to call them out individually as well as with their affiliations, because I think knowing where they work and knowing that they had the support from their organizations to participate in the advisory group is very important. So in no particular order, Andy Hoyle, who is with NOAA's Physical Sciences Laboratory out of the Earth System Research Laboratories in Boulder, Colorado. Jason Otkin, who is with the University of Wisconsin at Madison. Mike Hobbins, who is with the Cooperative Institute for Research in Environmental Science at the University of Colorado, Boulder. He works not only with CERES, but also with NOAA. And finally, Mark Svoboda, who, as everybody knows, is the director of the National Drought Mitigation Center, which is based at the University of Nebraska in Lincoln, Nebraska. So a big thank you to those 4 individuals for all of the work, the insight, their technical expertise, and just for their support of NIDIS in putting together this workshop. We will be sending out follow-up materials via email to all of you all, including a workshop evaluation, and we would very much be grateful to you all if you took the few minutes to do the workshop evaluation, especially in the world of virtual meetings. We have a lot to learn about how to put on engaging virtual workshops, so we would appreciate your response to that evaluation. We will be putting together a workshop report, and our intention is to get a very good draft together of this report, and then we'd like to share it with the attendees of this workshop so that you can have some ownership, provide your comments, as well as any feedback to the report before we release it. And we will also be sharing the PowerPoint presentations that you saw over the last 3 days, as well as the recordings. And so with that, I want to wish everybody a very happy and healthy and safe holiday season. And thank you once again for participating in this. Goodbye.